All right, once again, anytime you recognize that you're multiplying two binomials, have the same terms, opposite sign between them, you can look to use this pattern. And again, the pattern is take the first term, 2x, square it, subtract the second term, 5, and square that. And that's your whole pattern. Just simplify what you have. 2 squared is 4, x squared. Always a minus in between, 5 squared, 25. So it should be that quick. You should be able to answer this using the pattern. You don't need to FOIL because the outer and inner products are going to cancel each other out. Okay? The same kind of thing holds true with the binomial square. Okay? If you take a binomial and you square it, when you look at this, you should be able to see the pattern is first term squared, so 2 squared, x squared, and then it's plus the sum, or it's plus the double the product of the terms. So if you take 2x times 5, you get 10x. Double that, you get 20x. And then the last term of your expanded form is just the second term squared, so 5 squared, which is 25. So here is what your expanded answer would look like. Okay, now, when you're checking for, or if you're looking to use binomials that have a minus, the same exact pattern's used. You don't have to change the wording that you use or the pattern at all. Okay, all you simply have to do is apply the exact same rules, which is first term squared, so 4x squared, double the product of the terms, so 2x times negative 5, you do have to include the sign with it, is a negative 10x. When you double negative 10x, you get negative 20x. And then your last term squared, it's still a negative, but negative 5 quantity squared becomes a positive. Okay, so you don't have to think of separate rules for the sum and the difference of terms in your binomial square. It's always the same rule. Okay, and then the final one is the one that is new to you. And so again, the way that I'd suggest that you approach this kind of a problem is you identify the pattern of the coefficients. The pattern of the coefficients for a binomial cube is 1, 3, 3, 1. Remember, if you don't remember this offhand, just start building Pascal's triangle where you're adding the two numbers above and writing the sum below. Again, you should recognize that this is the pattern for binomial square, which means the next pattern is your binomial cube, 1, 3, 3, 1. Okay? And then what you're going to do is you'll take your first term, 2x, and you're going to cube it, square it to the first, and then to the 0, so you don't need to write anything in your last term. Then you take your second term, which includes the sign, and you cube it on the end, working backwards, square it to the first, and then nothing. And just connect each of these with a plus, and now you simplify to get your final answer. So your final answer when you cube 2 and x, here you square 2 and x, and then combine. So if you're looking at 5 times 4 is 20 times 6, or times 3 is 60, x squared. Here you square the 5, giving a 25. 25 times 2 is 50, times 3 is 150, x. And then you cube your 5 plus 125 to get your final answer. And now, again, if you were taking the difference of terms and cubing that, the process is going to be exactly the same. The pattern of coefficients is 1, 3, 3, 1. Take your first term, 2x, cube it, square it to the first. Take your last term. Now your last term is a negative 5, so you're going to cube it, negative 5, square it, negative 5 to the first. Connect everything with an addition symbol. And then when you go to simplify, all the negatives will take care of themselves. So here, once again, you have 8x cubed. Here, you get the same thing where you square these, but you have this lone factor that's negative, so it's going to be a minus. And when you're looking at this, minus 6x squared. Here, this negative is going to be squared, and so you get rid of the negative, it becomes a positive. So you get plus 150x. And then here, this negative is going to be cubed, so it will stay negative. And so the difference that you would get between a sum of terms and a difference of those terms when you cube it is accounted for. It's built into using these patterns to identify. Okay? So once again, my expectation is that you will be somewhat familiar with working through these binomial cubes. Again, if you get one on the final, you'll have a bit of time that you can check your answer, but you should be able to work through it without as well. All right, I want you to attempt the problems on page 24, sample problem number 6. Okay, I'll copy that and paste it here on the next slide. All right, the binomial cube at the end works the same way. It's the sum of terms, but the pattern's the same. Take your pattern of coefficients, 1, 3, 3, 1. Your first term is x. We're going to cube it, square it to the first. Our last term is 4. We're going to cube it, square it to the first. An addition symbol in between the terms. And now you just simplify what you have. So you have your x cubed as your lone term to start. There's nothing to simplify here, so 4 times 3 gives you 12. X squared. Here the 4 squared is a 16. 16 times 3 is 48. X. And then 4 cubed is 64. Again, all the signs are positives. And that would be your simplified form.